Students, welcome to Sourav sir's classes. The question is, the matrix M is equal to 1, 2, 3, 0, 4, 5, 0, 0, 6. Option A is an elementary matrix. Option B can be written as a product of elementary matrices. Option C does not have linearly independent eigenvectors. Option D is a nilpotent matrix. Now, an elementary matrix is such that it differs from the identity matrix by one single elementary row operation. But here, one single elementary row operation would not give us an identity matrix, so it is not an elementary matrices. Can be written, option B can be written as a product of elementary matrices. If mod m not equal to 0, that is, it is invertible, then the matrix can be written as a product of elementary matrices. So here mod m is equal to 1 into 4 into 6 minus 5 into 0 minus 2 0 into 6 minus 0 into 5 plus 3 0 minus 0 into 4, so gives us 24. Now since this is not equal to 0, it is invertible and thus it can be written as a product of elementary matrices. So the correct option is option B. The next question is, let the mappings T1, T2, T3, T4 from R3 to R3 be defined by T1 xyz is equal to x squared plus y squared, comma x plus z, comma x plus y plus z. T2 xyz is equal to y plus z, z plus x, comma x plus y. T3 xyz is equal to x plus y, comma xy, comma x minus z, and T4 xyz is equal to x, comma 2y, comma 3z. Then which of these are linear transformations of R3 over R? Now let us check it by a very simple logical reasoning. So we'll check the degrees of the equations. Now here, this is a 2 degree because we have x squared plus y squared, so it cannot be linear. In T2, we have y plus z, z plus x and x plus y, which all have a degree of 1, so it is linear. In T3, x plus y is linear, x plus y, x into y, now this has degree 2, so this is non-linear, and x minus z is linear. And T4, x, 2y and 3z all are linear since all have 1 degree. So T2 and T4 are linear, so the correct option is option C, that is T2 and T4. The next question is, let T is equal to 1, 0, 0, 1, 1, 0 and 1, 1, 1. Then the matrix of the linear transformation defined by Tx, T bracket x is equal to Tx with respect to the basis B is equal to 1, 0, 0, 1, 1, 0 and 1, 1, 1 over R is, we have been given the matrix T. Now let 1, 0, 0 is equal to V1, 1, 1, 0 is equal to V2 and 1, 1, 1 is V3. Define E1 to be equal to V1, E2 to be equal to V2 minus V1 and E3 to be equal to V3 minus V2. Now TE1 is equal to E1 plus E2 plus E3 and TE2 is equal to E2 plus E3 and TE3 is equal to E3. Therefore, TV1 is equal to V1 plus V2 minus V1 plus V3 minus V2 is equal to V3. Now similarly, E2 can be replaced by V2 minus V1. So V2 minus V1 is equal to V2 minus V1 plus V3 minus V2. That is equal to TV2 is equal to 2V3 minus V1, and TV3 is equal to TV2 minus V2 plus V3, that is 2V3 minus V1 minus V2 plus V3 is equal to 3V3 minus V1 minus V2. So therefore, the matrix of the linear transformation becomes, now see, TV1 is equal to, now coefficients of V1 and V2 are 0 and V3 is 1. So 0, 0, 1. TV2 is equal to 2V3 minus V1. So minus 1, coefficient of V2 is 0 and coefficient of V3 is 2. And TV3 is equal to 3V3 minus V1 minus V2. So minus 1, and 3. So the correct option is option A.